Welcome to this video on the review of the characteristics of linear, quadratic, and exponential functions. By the end of this video, you should be able to identify and describe the characteristics for linear, quadratic, and exponential functions. So just a quick review of some terminology that we're going to need. A line is a function whose degree is 1, meaning the highest exponent is a 1. The graph of a line is a straight line. Then we have our standard form and our slope-intercept form. A quadratic is a function whose degree is 2. The graph of the function of a quadratic is the U-shaped parabola. And then we have our standard form and our vertex form of the quadratic. And finally, an exponential function is a function where the variable is in the exponent, and then here is our standard form. And so the graph of an exponential function starts low and goes real high real fast, or starts high and comes down low really fast. All right, so our next part is just a bunch of vocabulary. Let's see what part you remember. The blank is the set of input values, or x values. So that's going to be our domain. The range is the set of output values, or y values. So we're only talking about y values when we talk about range. The x-intercept is where the line crosses the x-axis. And you can have more than one x-intercept. It depends on the graph. And then we have solutions. Solutions are known by a bunch of other names that we've discussed. They could be called roots, zeros, or x-intercepts. They all mean the same thing. It's where the graph crosses or touches the x-axis. All right. The y-intercept is where the graph will cross the y-axis. When a function is rising from left to right, so whether we got an exponential function or we have a line, it's rising from left to right, it's increasing. And if a function falls from left to right, it's going to be decreasing. All right. Next we have, this is other words for slope. This is rate of change. That's our rise over our run. The end behavior is going to look at the direction that the function points. Okay, so a lot of times it will talk about, often it's not going to say the left or the right, but it will say as x approaches negative infinity. X's are negative on the left-hand side of a graph. They want to know what's happening to the y values. So as the x's get smaller, what are the y values doing? Are they getting bigger or smaller? As the x values get bigger, because they're going towards the right, they're going this way. This one says we're going this way. As the x values get bigger, what are your y values doing? Are they getting bigger, or are they getting smaller? Are they approaching an asymptote? It depends on the original graph. Next, we have the axis of symmetry. It's a line that divides a parabola into two symmetrical mirror images. Remember, we would have the axis of symmetry go right down the middle, and it went right through the vertex, and we would name it by the x value of the vertex. Next, we're still talking about the vertex. The vertex is the turning point. That's where the graph turns around. And so the vertex can either be, if it's the highest point, it's called a maximum. And if it's the lowest point, meaning our graph turned this way and our vertex is on the bottom, then it's going to be called a minimum. And then the final one, the asymptote, is the horizontal line an exponential graph approaches but never ever touches. So when we had, so you would have an asymptote that would be horizontal, and on one side your exponential function will be really close to it but never touch it, and then on the other side it will be moving away from it. Alright, let's review what these look like when we're actually looking at a graph. Alright, when we're looking at graphs, a lot of times they'll have arrows on the end of them, but if they don't actually have exact points written on there, you can assume that there's an arrow on the end of your graph. So domain, remember, is all your x values, and it's talking about the left and right. Does it ever stop going left? And does it ever stop going right, whichever graph we're talking about? In this case, this line never stops going left or right. So we're going to have all real numbers as our domain. It's never stopping going left to right. Now our range talks about our y values. Range is read from the bottom to the top, and this graph never stops going down and it never stops going up. It doesn't turn because it's a straight line. It goes forever up and down. Our range here is also all real numbers. Next, we have the x-intercepts, where the graph crosses the x-axis. So here's our x-axis. So that's the point at which it crosses. So our x-intercept is at 2, 0. Our y-intercept is where the graph crosses the y-axis. So here's our y-axis. This is the point where it's crossing at 0, -6. When we read our graphs, we always have to read them from left to right. So as we're going across left to right, we would be going up this graph, so it would be increasing. So rate of change, it doesn't give over a particular interval here because with a line, it's always the same. So I'm going to just use my slope formula. So I have my 2 points, 0, -6, and 2, 0. And I'm going to plug them into my slope formula. Y minus y divided by x minus x. So 0 minus -6, that becomes +6. 2 minus 0 is 2. 6 divided by 2. So this says we have a slope of 3. So if I go rise 3, 1, 2, 3, and run 1, I'm on my graph. Rise 3, run 1 on the graph. Rise 3, run 1. I was a little bit off there when I was counting on the graph, because our slope for a line is constant. We don't need to know a particular interval because it's going to be the same each time. Now, our end behavior. As x approaches positive infinity, x's are positive on the right-hand side of the graph. So look at the right-hand end of the graph. As my x values get bigger, what are my y values doing? They're going up. So as my x's get bigger, my y values are going to get bigger, and they're not ever going to stop, so they're heading towards where y's are positive infinity. As x approaches negative infinity, that means the left-hand side of the graph. As my x values get smaller, my y values are also getting smaller because they're going down, so they'd be heading towards y values are negative infinity. Because the arms go in opposite directions, we have opposites when it comes to our end behavior. Okay, let's take a look. We'll start with the end behavior for this quadratic. Remember, if there's not exact points on the end, assume that they're arrows. Now, the arms of the line go in opposite direction. Do you notice the arms of the quadratic go in the same direction? So it says as x approaches positive infinity. So as the x values are getting bigger, where are the y values going is what this is saying. They're heading down, and y values going down go into negative infinity. And on the left-hand side of the graph, as the x's approach negative infinity, meaning as the x values get smaller because they're going towards the left, what are the y values doing? They're also going down towards negative infinity. These are pointing in the same direction, so these say the same thing. These were pointing in opposite directions, so they say the opposite of each other. You just have to identify left and right. Okay, let's go back to our quadratic. Our domain here, it's never going to stop left to right because of the arrows, so we've got all real numbers. Now for our range, notice that the graph doesn't go past this point. The graph goes up to here and then turns around and comes back down. So for the range, all of our y values are going to be less than or equal to 8 because they're all underneath the vertex. And the vertex, remember, is that turning point at 1, 8. In this case, our vertex is going to be a maximum because it's the highest point on this quadratic. And we're going to say it's a maximum at the y value because we're talking about up and down. So it's a maximum at 8. Your line of symmetry, axis of symmetry, will go through right there. Divides the graph into 2 symmetrical areas, and we're going to name it x equals, because it's a vertical line, and the x value of the vertex, x equals 1. My x-intercepts, I have 2 here because my graph turns around and changes direction, so I end up with 2. I have one at -1, 0, and the other one's at 3, 0. My y-intercept is where the graph crosses the y-axis, so it's right here at 0, 6. Now, intervals of increase and decrease, these were a little harder for us when we did them the first time. So we were looking at each side of the axis of symmetry. Okay, so I got this side of the axis of symmetry, and if I was walking across, because we're always going to really read these from left to right, if I was walking across, when I hit this graph, I would start walking up. So this is an increase side. Then at your vertex, also called the turning point, we end up turning around and now we're going down, so that's our decrease side. Now, it's the axis of symmetry that's splitting us right there. So our axis of symmetry, remember we said, was at x equals 1. So if I am to the left of the axis of symmetry, I'm going up. I'm on the increase. So my interval of increase would be any x value less than the vertex, to the left of the vertex. So my x will be less than 1. At that point, I turn around and start heading down, so now I'm on my decrease, and the whole decrease side is to the right of the axis of symmetry, so all your x values will be greater than 1. Okay, that takes a little extra practice. And then our last question, rate of change over the interval. So this is slope. So I'm looking where x is -1, that's that point, -1, 0. And where x is +1, which happens right here at our vertex. Do you see the +1? So that's 1, 8. And now I use my slope formula. Y minus y divided by x minus x. So it was a 1 minus a -1. When I calculate this out, 8 minus 0 is 8. 1 minus a -2 becomes 1 plus 1, which is 2. So my rate of change is 4. And we could count, if we go up 4, right 1, up 4, right 1, we end up. It's really the slope of the line that connects those 2 points. All right, now our last one, the exponential function. There's no definitive dots on the end, so we're going to put arrows. Then we're never stopping going left, we're never stopping going right, so this is all real numbers. My range, see how the graph flattens out right here? It's never going to go below this asymptote, so I'm just going to follow that along and keep going straight across. Okay, there's my asymptote. It is at y equals 1, 2. It goes through the y-axis at 2, so y equals 2 is my asymptote. And the reason I'm naming that is because now that's going to help me with my range. The entire graph is above the asymptote. It will never touch the asymptote or go below it. So the entire graph is above this. But it can't touch it, so we're not going to use an equal to sign. We're just going to use a greater than. And it went through the y-axis at 2, so my range is y is greater than 2. My x-intercept, because I can never pass my asymptote, I'm never going to get to the x-intercept. So I'm going to write none or not any. Don't leave it blank. Some indication that there isn't one. Do not put a 0 because a 0 is a number. My y-intercept is where the graph crosses the y-axis, here at 0, 3. Growth or decay, this starts off small and gets really big, so it grew up So this is a growth. So it's going up from left to right. That makes it increasing. And now let's look at the end behaviors. As the x approaches positive infinity, so as the x values are getting bigger, meaning on the right-hand side, where are your y values going? The right-hand side is going up forever, so it's heading towards where y's are positive infinity. On the left-hand side, where x's are approaching negative infinity, meaning where x's are getting smaller, you see how it's riding along this asymptote. It's just going to get closer and closer and closer to that asymptote, but never ever touch it. So it can't go to negative infinity because it can't cross that line. So on the left-hand side, we're just getting closer to the asymptote, so we're going to say we're approaching 2. So your end behavior goes well with your range. Okay? Now let's look at our rate of change between 0, 3, and 5 and 15. I've had 2 points, so that's a slope formula. So we're saying y minus y divided by x minus x. 15 minus 3 is 12. 5 minus 0 is 5. This will not simplify, so we're just going to use that for our slope, 12 over 5. I hope that was a helpful review. Let me know if you have any questions. See you in class.